Hi folks, welcome back. So today I thought I'd do something a little bit different, and instead of covering a paper, I want to go through a post I made on my blog recently. If you look at the modern landscape of operating systems, you will notice that Unix has basically won. And I want to talk about my subjective view on how and why that happened. But more importantly, I want to extrapolate some of the trends we're seeing in hardware and in operating systems to think about what operating systems of the future might look like. In this treatment, I'm using the word Unix very loosely. I'm using it to cover basically the entire Unix family tree. And that has many Unix-like operating systems. It obviously has Linux, it contains Android, it contains Mac OS X, which was based on the Darwin kernel. It contains things like Solaris and Sun OS and the BSD distribution. So the original Unix operating system that came out of AT&T Labs spawned quite a wide family tree of operating systems that either descended from it or were heavily influenced by it. Now, just in case you're wondering, how exactly did Unix win? If you look at the numbers, it's pretty clear. In terms of the number of devices shipped, Unix beats everyone else hands down. If you just look at Android alone with its billions of shipments, iOS also ultimately derives from Mac OS, which ultimately derives from Unix. And then if you look at everything in data centers, everything in the cloud, on the server side, the vast majority of that is Linux. On the desktop, about the only non-Unix operating system that is viable and common is, of course, Windows. But everything else pretty much is some form of Unix. So how did Unix win? If you look at some of the original papers describing Unix, you will see how some of the core abstractions, things like the hierarchical file system and interactive shell, processes, pipes, all of these haven't changed very much in all the decades that followed the initial conception. These abstractions would not have been so enduring if they were not good abstractions. And programmers really took a liking to these abstractions because of their simplicity and their power. And I think that is what enabled Unix to basically keep getting carried forward in the minds of programmers and geeks. The other big thing was portability. Unix was one of the very first operating systems to be written in a high-level language like C instead of in the assembly language of the specific machine on which it was running. And this was huge because it enabled a lot of ports to various architectures. This is really interesting. Historically, AT&T was forbidden from selling things that were not related to its core telecom business because of an antitrust suit that the United States brought against it. Unix, since it was not related to its core business, could not be sold. And so AT&T licensed it very cheaply to various universities, including UC Berkeley. Evan Hunt on Twitter tweeted out this really interesting piece of history, which was that when AT&T licensed the source code to Berkeley, it was classified as industrial waste for tax purposes. And as a result of this, you had an entire generation of computer science students, both undergrads and grad students, as well as PhD students, that basically grew up on Unix. A lot of them did their dissertations, building stuff out on top of Unix. And so Unix really spread a lot through academia. And when all these people graduated, they wanted to keep working with Unix, and then they spread Unix in corporations. This is an old trick which every major tech company tries to do, except in this case, it happened organically. And then the next big thing was the internet. And there's no question that the internet was natively developed on Unix. The entire suite of utilities and daemons and protocols and tools that make up the machinery of the internet was basically built on Unix, and to a large part was built by people who came from the Unix tradition. BSD, which was the version of Unix developed at Berkeley, open sourced its TCP/IP stack, and that is what kicked off the wide adoption of TCP/IP outside the military. And fast forward to today, we now have Linux dominating the Unix space. Linux is now in a virtuous cycle where its continued success feeds its future success. There has just been such a massive amount of engineering that has gone into making it solid that whenever you're faced with choosing a kernel for a new project, the default choice is Linux. It's just not feasible to build something outside of Linux and then miss out on all the community contributions that go into the mainline Linux kernel. And that's why you see the Linux kernel underlying Android, even though it's on the extreme other side of the hardware spectrum. So that was a look at some of the historical reasons why Unix came to dominate the operating system landscape. Now, how and why, looking to the future, would we want to move past Unix, or would we want to do something differently? In my mind, the biggest reason to re-examine Unix's dominance is the sheer complexity it now has. What started as a small set of clean, simple, elegant, and powerful abstractions have accreted an enormous amount of complexity over the decades. If you look at the POSIX spec, it is 3,000 pages long. And the reason that's happened is because it wants to address a wide variety of use cases. But if you look at any one specific application, you really have to ask if you need to support all of that complexity or just the tiny subset that your application needs. At the same time, the hardware landscape has also changed a lot. Back when Unix was first developed, I/O was orders of magnitude slower than CPU. And so that gave you a lot of CPU cycles to burn to provide all these high-level abstractions like a hierarchical file system. But fast forward to today, CPU speeds have plateaued, and cutting-edge I/O devices like the fastest network cards can easily saturate a CPU. And this is leading a lot of people to question the very idea of all these general purpose but heavyweight abstractions. The very idea of having all these abstractions in the operating system is coming under attack. You have frameworks like SPDK and DPDK which forego all the abstractions in the kernel and get raw access to the underlying hardware like the network or disk, and then roll their own abstractions purely in user space. You also have to look at the application level experiences that users are getting. If you look at modern application stacks like Android or Chrome OS, they are hermetic enough that the underlying operating system doesn't really matter to the end user. For all practical purposes, for web applications at least, the browser is essentially the OS. Add to that, if you look at how a lot of programming targets a virtual machine, like a Java virtual machine, rather than an underlying operating system, it just goes to make programmers much more invested in their runtime and VM rather than the underlying operating system. And so you have to ask, what does a modern operating system look like? If you had to design a new operating system looking at the application and hardware landscape that exists today, what design principles would you choose, and would you choose the same principles that Unix and its successors were built on? If you look at Fuchsia, for example, it's going towards a microkernel-like architecture with capabilities, where there's a very small kernel guarding hardware access, but then almost all the services that traditionally lived in the kernel are pushed out to user space. Now, the idea of microkernels and capabilities are not new ideas. They've been discussed and researched heavily in academia, but they could never really get real-world traction because in the real world, the engineering cost, the barrier of making a viable operating system is so high. This is kind of the point that Rob Pike was making in his talk titled Systems Research is Irrelevant. If you haven't seen that, I highly recommend it. But all these trends, I think, are finally beginning to dislodge the dominance of Unix, and people are finally again beginning to consider different trade-offs in terms of abstractions and the costs of those abstractions and how those abstractions are exposed to applications and so on. So operating systems are becoming interesting again. If you have any thoughts on Unix or how you think future operating systems might look like, please let me know in the comments. I hope you enjoyed that, and I will see you next time. Thank you very much.